Well, good morning, everybody. I'm Victor Eventos. This is Miguel Garcia and Jose Diaz, and we're GreenDev. So this is a brief outline of our presentation. Okay, to our presentation, we're going to be talking about Pragma. Pragma is a web application which reduces the problem of over and under irrigation on farms in Puerto Rico, which in turn increases the crop yield and farmers' revenues. Okay, so how does it do it? Well, it provides the farmer with the needed irrigation water volume based on the farm's location, the latest climate data, and the last irrigated date. Most importantly, it leverages Dr. Hampson's GoPR web algorithm for hydroclimate variables. Here we have the system overview. We can see that we have 4 different main components. First, the process automation is fed with the input data from the GO satellite and the NetStrat radar. Then that data is stored in the database server so that the application server can serve all the requests from the front end. We have 2 main users. First, we have the farmer that can access the full-fledged application, and the researcher can only access the research data. Now I'm going to leave you with Jose.
Alright, so I guess you're wondering how Pragma actually works, or how it actually looks. And I'm going to give you a brief demo on how it actually works. Okay, so this is a video showing the landing page of our application. Here you have your standard business information and sections for about us and registering a researcher and a farmer alike. So let's go ahead and sign up as a farmer. Okay, by clicking on the sign up, you will be prompted a form with your standard fields such as name, last name, organization. But the key aspect here is that you get to pick your farm coordinates. You being a farmer get to search whether your farm is located anywhere on the map on Puerto Rico. Here in this case, the test subject shows Maya West. Alright, so logging in our username and our password, and we click sign up. Alright, so we arrive here at the login page. So we just enter the same credentials we just registered. And after this, you'll be prompted to an overview page. Let's take a look at that. Alright, so the overview page shows us general weather information about Puerto Rico. Here you have your weather forecast for the whole island. And to the right, you have a rainfall map which shows rainfall values for yesterday's date and today's weather widget. Now let's move on to our crop sessions. Crop sessions here, obviously you have no crops planted whatsoever, but now let's go ahead and create one. So by creating one, you get to pick your name, the type of crop type obviously is needed, and your crop area, or the area it encompasses. Obviously you get to choose and pick the date where you created it, where you planted it. So you choose the March 15th for this example, and click save. Now you can see that you have a crop in your crop management session. Alright, let's click on the name, and it'll take us to the main view. So you have 4 different sections in this view. Let's take a look at the most impressive one, which is the crop coefficient one. It's this graph you see right here. It's values that are specified for each crop type individually. They are preset for scientific values, but you can change it if you like, if you know that your crop section has a specific stage difference. Okay, so for the main purpose of the app was to calculate the crop's water requirement, and so we're going ahead and choose a date, which is April 1st, and it's going to tell us how much water we need to irrigate from that date towards today. So we click calculate, and after a few seconds, the app will tell us how much water it needs from April 1st till today, or the day that we recorded this. Okay, so we see the volume change in a few seconds, and it'll tell us the gallons of water. Okay, so we get 41,000 gallons of water. Remember that our crop is 2 acres, and it's obviously a month period. But they can save, we see it recorded in our irrigation history section, and you see a table and a graph being plotted. So you can actually appreciate the graph. We'll go ahead and create another irrigation event 1 week further from that one, and it'll hit calculate again and recalculate what we should irrigate from that point on to today. Okay, so here to the right you have also the crop summary, which have important dates. And after our app crunches in the numbers, we will get a different volume value. Okay, so we got 15,000 gallons. Let's click on save and scroll down to the irrigation history section again. So you see it recorded our irrigation event and plotted the event. Okay, so moving on to the research aspect of the app, we can see that by clicking on the research tab, you get a table with all the GrowthPR web supported variables. These are variables that Dr. Harmsen's algorithm uses to estimate values for a specific location. So now let's move on to another view, which is the plot data. And here you could actually choose the longitude and latitude of your location in Puerto Rico, the variable you want to choose to plot, and a specified date range. So you want the values for rainfall. In this case, he's going to choose value in March 1st, and the end date. And after that, you will see time series values plotted in the bottom of the page. So click on plot data, and after the app finishes loading, you're going to see the values plotted. Let's give it a few seconds, and then here it is. Those are the rainfall values for that specified date range. Okay, so those are the main features that Pragma has. Obviously, it has a lot more, and you can see it offline in the demo section. But for now, that's the demo. So let's move on to what methodologies we actually use. So all code was test-driven development, which is we describe first and write the test and then code. We obviously use the model view controller for the front end and back end. And we use object-oriented design patterns for the GrowthPR web automation Java program we wrote. And coding quality was enforced by Lynchens. So I'm going to leave you with Miguel, who's going to talk to you about the technologies we use.
Okay, so to actually build this, we had to use multiple technologies. For the front end, we use Angular.js, and for the back end, we use Node.js. This allowed us to use JavaScript across both front end and the back end. To handle our massive data sets, we use PostgreSQL as the database, and we use Java to make the GrowthPR web automation. To bring this all together, we use GitHub to effectively collaborate and keep track of our code contributions. In terms of assessing the project, we have been able to meet all the project objectives as presented in the proposal at the beginning of the semester. And on April 28th, we presented and delivered the project to Dr. Eric Harmsen. In terms of the individual components, all 4 components are at 100% completion. In terms of the budget and market, we had projected approximately $300,000 to expenses to operate Pragma as a business for a whole year. Fortunately, since we built Pragma as part of the Capstone project, we did not incur any expenses for payroll, and as such, the total yearly expense for Pragma was reduced. In terms of the price point we would be targeting if we launched Pragma as a business, we'd be looking at $49 per month for each farmer that subscribes to Pragma. In terms of the market and its size, we are targeting small to medium-sized farms in Puerto Rico, and this is approximately 13,000 farms. To conclude, I want to highlight the impact of the project. First is that we are able to increase crop yields through better irrigation, and additionally, we can help create awareness in farmers as to the importance of proper irrigation management. In terms of the future work, we'd like to increase the number of available crop types in the application and possibly expand our coverage to the Española Island and Jamaica, since we also have access to this data. Thank you, and I will open it up for a short round of questions.
de lluvia eran sostenidos a base de orquestadas de satélite, ¿verdad?
Sí.
No es lo que es entonces un grid de este tamaño.
Es un grid que divide a Puerto Rico en celdas de 1 kilómetro cuadrado. Esa es la resolución que utiliza.
Como dijiste, Mayagüez era la zona.
Sí, la zona. Como es de 1 kilómetro cuadrado, pues no es pinpoint accuracy para el mapa, pero sí le da un número bueno suficiente para efectos de estos cálculos.
Que Mayagüez tiene al lado sur a Hormiguero, que son 60 pulgadas, pero si nos vamos a Miradero o hacia acá, son 80 pulgadas de lluvia.
Sí, que puede variar en esa región, pero ahí pues, como la persona actually puede poner un marker, el programa está hecho que va a escoger la celda más cercana a su localización exacta. Y ahí tiene los números más cercanos.
La curva que parece un trapezoide de ATV, si esa es la forma de crecimiento, pero solo me llamó la atención. El aguacate no tiene una cosecha recién sembrada.
Pues,
El aguacate tarda varios años.
pues la curva de cassette, el error coefficient que vimos, es para el season completo. O sea que el length que tiene, toda esa data viene del Departamento de Agricultura Federal. Esos son los valores estándares y cada agricultor puede ajustarlos a sus necesidades. Si ellos conocen que su aguacate se tarda más aún o tarda menos, pero los valores que tenemos fueron todos sacados con la data estándar y el agricultor entonces puede modificarlos a su necesidad.
Esa curva se ve más típica para los cultivos que son semianuales o anuales.
Sí.
El aguacate pues tarda 3 o 4 años antes de tirarme el primer aguacatito.
Y bueno que eso no va a ver.
No me quedó claro si lo que estás calculando es la cantidad de lluvia que está cayendo o la agua que se necesita para que crezca.
Es la cantidad de agua que tienen que irrigar, y para lo que se utiliza la lluvia es porque nosotros, entre las variables que tomamos en cuenta, hay una que se llama evapotranspiration, que es básicamente la acumulación de evaporación y de transpiración que ocurrió en la planta, y entonces a eso se le resta la lluvia porque no hay que replenish it. Y entonces pues tenemos un volumen de agua en galones que le damos al agricultor para que le eche.
Y la otra cosa es, tienen la ecuación que usa porque no es lo mismo irrigar en terreno pedregoso que en terreno arenoso.
Sí, la ecuación que utilizamos la obtuvimos a través del profesor con el que estamos trabajando, que es Eric Harmsen de Agricultura, de la Ingeniería Agrícola, disculpe. Y es la estándar que usan para cuando se utiliza el método de calcular la irrigación usando evapotranspiration, usa la fórmula de nosotros. La podría ver después de la presentación, la puede ver con nosotros si quiere para conocer un poco más de eso.
Quiero aclarar que es un proyecto de investigación del Dr. Hans.
Sí. Ella menciona que este proyecto es una ampliación de un proyecto de investigación de Dr. Eric Harms en Ingeniería Agrícola. Sí, él estuvo en nuestro happy hour, pero nos había mencionado que por compromisos de clase y de otras cosas no iba a poder estar presente.
Mencionaron un precio ahí mensual. ¿Están
Sí.
pensando montar una empresa?
Pues lo hemos considerado y lo hemos hablado con el profesor también. A él, lo primero era contar con la aprobación de él, si él tenía interés o no, porque es algo que se trabaja en conjunto con él. Él dijo que sí, que le daba la atención, y el precio que mencionamos de $49 mensuales, entendemos que por cálculos que hemos presentado en otros documentos durante el semestre, el ahorro que le trae a un agricultor debido al aumento de su productividad, del rendimiento de sus crops, pues aguanta un precio de $49 mensuales. Y esto nos permite recuperar cualquier inversión inicial en un periodo aproximado de 24 meses. Sí, el proyecto se va a seguir desarrollando con el profesor durante el verano posiblemente y durante el semestre, y entonces se harán pruebas con agricultores. Él tiene varias personas que están interesadas en probarlo. Bueno, pues gracias por su tiempo.